In the previous section, we worked with expressions, where you added or subtracted or multiplied or divided together different variables and terms. But you didn't actually find a solution for what those variables were, usually. You described a scenario. The difference here is with equations, there's an equal sign, and your goal is to find an answer. To solve an equation, we will use inverse operations. The inverse of addition is subtraction. The inverse or opposite of subtraction is addition. And multiplication and division are opposites as well, or inverse operations. They can undo each other. One of the golden rules here in Algebra 1 is that what you do to one side of the equation, you must do to the other side of the equation. So I like to start with the variable. Y is on the left, so I know I'm trying to get y all by itself. I'm trying to get rid of everything else that's there, which is minus 8. Minus 8 is subtraction. What's the opposite of subtraction? That's plus 8. If I draw a line down through my equal sign, that reminds me that I have to add 8 on the other side as well. These two cancel out, because plus 8 and minus 8 is just 0, so they go away. And I'm left with y is equal to 32. I start with my variable. It's on the left side. It's not there all by itself. There's a 9 there. I want to get rid of the 9. As written, what this means is 9 times y. When two things are written together like that, 9 is the coefficient. It means multiply it by this variable. So what's the opposite of multiplication? It's division. I'm going to draw a line through the equal sign to remind myself where else to divide. 9 divided by 9 is just 1, so that's why we draw a line through it, because it goes away. And we're left with y is equal to 12. Z is on the right side. It's not by itself. I want to get rid of this. Minus 7 over 16 represents subtraction. To undo that, I'm going to use addition. Remember where my equal sign is, and add on both sides of it. One's on the left, one's on the right. This part goes away, becomes 0, and on the left, I can add two fractions when the denominator is the same. It's just 5 plus 7 is equal to 12 over 16. This isn't necessarily my final answer because I can simplify this fraction. I can look for a common factor by dividing the numerator and the bottom by 4. And this changes things to 3/4, which is the simplest form and my final answer. This one is tougher to spot because we don't see it written in this form as often. When we have the fraction j over 3, that really means j divided by 3. So we start there with j, and we want to undo that division. So we multiply by 3. And on the left, we multiply by 3 as well. 3 over 3 cancels out. So we have j, and what is negative 8 times 3? It's a negative 24. If we're multiplying two numbers and they have different signs, it always comes out negative. If we're multiplying two numbers and they have the same sign, it always comes out positive. Since this equation adds 17 to m, I can subtract 17 from both sides. Remember that this is where my equal sign is, so I have to subtract 17 from both sides. Here, the 17's go away, and I'm left with m is equal to 16. n divided by 6 I can cancel out by multiplying by 6. And if I multiply the left side of the equal sign by 6, I have to multiply the right side as well. On the left, 6 over 6 is another version of 1, and 1 times n is still n. On the right, if I take 2.8 times 6, I get 16.8. As written, t has plus 1.8. I can cancel that out with subtraction. If I do that on the right side of the equal sign, I have to do that on the left side of the equal sign also. This goes away, and I have 2.4 is equal to t. This is what this section of the quiz will look like, about 6 problems. We start with the side that has the variable. If it says -7, put a +7, but do it to the other side too. If our variable has a -8 in front of it, that does not mean subtraction. That means -8 times m. So we divide by whatever is in front of it, which happens to be -8. We must do the same thing to the other side of the equal sign. Here this becomes 1, and 1 times m is still m. On this side, it's a positive divided by a negative. They have different signs, so it always comes out negative. If we have a fraction in front of our variable, like 3/8, we can solve this by multiplying by the reciprocal. So 3/8 we can multiply by 8/3. And if I rewrite this, it's a little bit more clear that 8/8 cancels out and 3/3 cancels out. And we are left with just x. On the right side, we have 3 times 8/3. You can do the shortcut where you cancel out the 3's and you jump straight to 8, but you can also take 3 times 8 is 24, divided by 3 is 8. A plus 2.4 is 19.5. If I subtract 2.4 from both sides, I can find out directly what A is. And that is 17.1. 8 divided by 7. That's what this fraction bar means. It's the same thing as 8 divided by 7. If I want to cancel out division, I multiply this side by 7 and I multiply this side by 7. And the division and the multiplication cancel out, and I have 42 is equal to h. There's a 1/3 in front of x. To cancel that out, I take 1/3 x and I multiply it by 3/1, the reciprocal. 3/3 cancels out, 1/1 cancels out. On the left side, I have 3/1 times 3/9. You can multiply fractions straight across. 3 times 3 is 9, and 1 times 9 is 9. If 9/9 is x, another way of describing that is just as 1.